In this video we're going to look at how we solve quadratic inequalities. Now, in regular GCSE mathematics last year we would have seen how we could solve just normal inequality equations like this, and we did this by treating it as an equal sign. Instead of an inequality here, we treated it as an equal, so the whole thing was just like a regular equation. There were a couple of wee rules in there as well, a couple of wee exceptions, but how we look at this one, to solve this, you would just first thing you would do would bring that plus 1 across to the other side, and it would become minus 1. And tidy up, you have 2x is less than 2, and then you just divide across by the 2, so x is less than 2 over 2, so x is less than 1. You could also have drawn that on a number line. On a number line it would look like that. You would just mark a 1, and it's an open circle above the 1, and it's an open circle. It would have been a full circle, that would have told you the 1 is included, but here the 1 is not included. Okay, I'm just going to look at a couple of exceptions here, a couple of problems that we would have had last year. So another example on this, maybe I had, I'll just make one up here, 4 minus 5x is equal to, 4 minus 5x is equal to, is not equal to, is less than or equal to 16. Now what you might, if you do this one, a couple of ways you could do this, but if you go about it the way I'm doing it here, bringing the 4 across, it becomes minus, so you have minus 5x is less than or equal to, and that's going to be, minus 5x is less than or equal to 12. Then what you could do here is divide across by the minus 5, so you'll have 12 over minus 5. If you multiply or divide across by a negative, as I've just done, you must also change the direction of the inequality. So that would become x is greater than or equal to, and that would be minus 2 and 2/5. Okay, we're going to look now at how we actually solve our quadratic inequalities, and I'm going to jump straight to the examples here. There's a bit of notes for you to read through here in your own time, but we'll jump straight to the example. Okay, so this first example says solve x squared minus 7x plus 10 is less than or equal to 0. Now, always, if it is not a positive quadratic as this one is, and the second one, bring it over to the other side so that it becomes a positive quadratic. But they should always give you a positive quadratic at GCSE further maths. But if they don't, bring it over to the other side so that your quadratic term is positive. Just makes it so much easier to work with. Okay, how you do this? The first thing is you forget about the inequality. So you just put x squared minus 7x plus 10 equal to 0. And then what we want to do is solve this thing. So this is just a normal quadratic, and we want to go ahead and solve it. So my sum is equal to minus 7, my product is equal to 10. So my two numbers are going to be minus 2 and minus 5. I've omitted the working out for us to find that, but you should realize if your sum is two numbers add to give minus 7 and multiply to give 10, the two numbers are minus 2 and minus 5. If you can't see that, work through your products of 10 and see how you, your factors of 10 and see how you can get it. Okay, so you rewrite your equation as x squared minus 2x minus 5x plus 10 equals 0. And then factorize the first two terms. You'll have x minus 2, and then minus 5 upon x minus 2 is equal to 0, which means x minus 2 and then x minus 5. So that means x is equal to 2 or x is equal to 5. Okay, you have not done the answer just yet. What we've done so far, all this does is allow you to sketch what this quadratic looks like. So we're now going to sketch that. So just write down the word sketch. So sketch, and we now know it has roots at x equals 2, and x equals 5. So that means it crosses the horizontal axes at those 2 points. We also know it's a positive quadratic graph, so it's a U shape. So if you take that advice that I gave you earlier on about always having the x squared term positive, it will always be a U-shaped graph, which makes life an awful lot easier for you. Okay, you mark on the roots, so that's where it crossed, 2 and 5. That was our x-axis. And what we are looking for here, so now this is the first time we're actually looking at the inequality. And we want our inequality, x squared minus 7x plus 10, to be less than 0. So I'm just going to note at the side here, we wanted x squared minus 7x plus 10 to be less than 0. And we'll just say less than 0, so we want we want to find, we want to find when it is below the x-axis. That's what we're looking for. Okay, so it's less than 0, so we want to find out when it is below the x-axis. Okay, let's look at this graph. From here outwards, it's going to be above the x-axis. From here outwards, it's going to be above the x-axis. So it's only below in this wee section here. So it's only below between here and here. So your answer is 2 is less than x is less than 5, because we want that wee section between the 2 and between the 5. And notice these are less than signs, and it is a less than sign in the question. There's no equals bit here. That's the important bit. There's no equals bit. So there's no equals bit in our answer here. So they're just single inequalities without the equals bits. Okay, another example of this type. Same process, go through it again. We're going to put 3x squared minus 13x plus 4 equals 0. So we're forgetting at the time, for the time being, about the inequality. Your sum is minus 13. Your product is positive 12. And my two numbers again, that's a nice easy one for me to do, are going to be minus 1 and minus 12. I'm going to rewrite my equation as 3x squared minus x minus 12x plus 4 is equal to 0. And then factorize, take an x outside a bracket, 3x minus 1. Then over here, take a minus 4 outside a bracket, and you have 3x minus 1 inside the bracket. Write down your common bracket. It was 3x minus 1. And then it was multiplying x and minus 4, so equals 0. So that means x is equal to, put the first bracket equal to 0, you'll have 3x minus 1 equals 0, which means 3x equals 1, which means x is equal to 1 over 3. Put the second bracket equals 0, x minus 4 equals 0, which means x is equal to 4. Again, this was not our answer. This just tells us how we can sketch our graph. So we now know our graph, which was a U-shaped graph. It cuts at 1/3 and it cuts at 4. So that's where it cuts the x-axis. Now in this case, we want it to be greater than or equal to 0. So when is this thing above the x-axis? So it's above the x-axis out this way, and it's above the x-axis out this way. So to the left of a third means x is less than a third, and then comma, to the right of the 4 means x is greater than 4. Okay, one more thing to do here is look back at the original inequality. The original inequality was a greater than or equal to, so we need to add the equals bits to both of these inequalities here. So that's a very easy mark to throw away, so make sure you just check at the end, check what your inequality was, the original inequality. So we've now added in, so our final answer, x is less than or equal to a third, or x is greater than or equal to 4. Our last example for this video, we have to solve 4x squared minus 81. So just to show you that we can use other factorizing methods, so here we're going to factorize this using the difference of two squares. So first of all, we'll say that's just 2x minus 9 upon 2x plus 9 equals 0, first of all, so equals 0. And then that means x is equal to 9 over 2, or x is equal to minus 9 over 2. So that really means x is equal to 4.5, or x is equal to minus 4.5. So we can do our sketch. It's a positive quadratic, and it crosses, we now know, at minus 4.5 and at positive 4.5. And let's go back and think about what it's going to be. It's a less than or equal to, so this means we want below the x-axis. So it's below the x-axis between minus 4.5 and plus 4.5. So your answer is minus 4.5 is less than x is less than positive 4.5. And read the question again. I think that's right. Read the question again. Oh, no, it's not right. You've got to check. It's a less than or equal to here, so you need to add the equals bit to both of those. So I would have lost a mark there because I hadn't checked. If I hadn't checked, so go back and add those in, and that is your answer. Okay, you are now ready to do your CCA For the maths book, exercise 5A.